Welcome to the first developer highlights for the graph. With me today, we have an active community member and a subgraph developer beast, Juan. How are you?
Hi there, guys. I'm fine, thanks. And you?
Yeah, I'm great. So I'm excited to have you on. You've been working with UMA, Augur version 2 and Compound version 2, and also the graph network. How has that
Yeah.
been?
Well, it's been a wild ride. Let's say it like that, right? So lots of work, especially as of late with the graph network subgraph. There's been lots of work, and there still is a lot of work like going on, probably behind the scenes for many people, but there's a lot of work going on. Yeah.
So how did you first get involved with the graph?
Well, I actually started working with the graph when I first started working in Web3 actually, because I worked in I started working with Protofire, and like the first thing they wanted me to do was to start working with subgraphs, and I didn't know much about Web3 by at the moment. Like I was just like reading stuff about Ethereum and blockchain and whatever. So yeah, I basically went like straight into the subgraph development side of stuff. So I kind of started working there first. Of course, I didn't have much Solidity expertise yet, so I kind of studied while I was developing subgraphs. So it was like trying to learn two things at the same time, right? So how to develop subgraphs and how to read the code that I
Yeah.
have to like support with the subgraph. So it was kind of like it was challenging for sure, but it was like really really fun.
Yeah, it's tough getting or finding resources to learn working on subgraph development, at least as early as you were. So we hope to be able to supplement that with these videos and more. So
Like there wasn't much documentation more than like the official docs, right? So uh, it was thankfully I had like a few colleagues that were a little bit more experienced than me in the subgraph development like category or whatever. They've been working a year prior to when I started, so like 2 years prior to now. So they had a lot of experience, but of course, the graph back then, like a year ago, like was still not even it didn't even have a testnet yet. Like most stuff were just being developed for Ethereum and on the hosted service, and it was a little bit, well, not a little bit, but a lot smaller than it is now. So the documentation was only like the first versions of the official documentation. It was useful. You could do a lot of stuff with it, but you kind of have to like have a little bit of uh, let's say curious brain. You need to be really curious and have to try stuff yourself and see if that works or not. Thankfully, like we had a lot of support from the core the graph team, which is now called Node, but back then we knew it as the graph, and they were like the graph team. So they were really helpful, like teaching us how to do stuff and whatnot. So that was really 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 helpful.
yeah, what are we going to learn about today?
Well, we're gonna try to at least try to right to cover like some ways to future proof your subgraphs using templates. Basically, the idea is that you could like harness the factory and proxy patterns for Solidity development and like use them in a way that you don't really need to update your subgraph code so often, as long as there isn't like many big changes to event signatures or whatever. Like you could pretty much get away with just deploying a first version, and unless there's like a really big change at some point in the protocol that you're trying to support, you won't really have the need to update it. So yeah, that's what we are going to try to cover today. Let me share my screen. Okay, so I'm gonna use like one of the subgraphs that I made in the past, which is the loopring version 3.1. Basically, this one uses a factory pattern, right? So we'll go first showing this one. Let me 1 second. So to be very like brief with the domain that we're going to cover, basically the loopring contracts, like you have like the main loopring contract, which is this one. And this one is basically a factory. It will be creating or actually it's more like a registry, but it's basically a factory. What this means is like this one is going to be triggering events, right? Whenever a new exchange or a new contract or whatever is created. In this case, this one actually tells us when a new exchange is being created. So, and the exchange is the actual contract that we actually want to track all the events from. So we're going to be harnessing the factory type of pattern that this contract is using to be able to avoid having to hard code new exchanges whenever they become available. And we will have all those exchanges data available for us. So basically, just to give you a quick rundown, these are the exchanges. Like there's only two, but there could be many more. So it's basically the loopring decentralized exchange and the we decentralized exchange. I think it's called we or whatever. And if we go to the implementation that I prepared, this one is like the example without the template. It's just using a data source, not dynamic, but rather a like fixed data source, a static data source. And whenever we use static data sources, we basically have to define a name for the data source, which ABI is it going to use. In this case, it's just the exchange version 3 ABI that we're going to use. The other is for said data source, and this one is optional, but it's really useful if you need to like speed up your syncing speeds. You could actually like tell the subgraph the block that it has to start syncing for that specific data source. So basically, this field is like it lets you avoid having to sync 9 million blocks before starting, because those 9 million blocks won't be having any data that we are actually going to be using. You can actually check that. This is a small pro tip, I guess, but you could check the start block for any contract going to Etherscan. This is useful for ETH network, but it most likely any network has an explorer like Etherscan, so you could probably use it on others too. So you go to the contract that you want to check when it was first created. You go to the transaction, you open the link, and you basically have the block here. This is probably, it's too small. I don't know. Well, you have the block here, so you could copy paste this, like just copy here, and it's gonna be this one. Of course, it didn't indent properly. There we go. And well, basically without the templates, what you're going to want to be doing is like defining the event handlers as you would normally. And you will have basically everything set for your manifest, right? You have the address, you have the ABI, all the ABIs that it's going to be using. It's also using an ERC20 ABI because it's tracking a few transactions here and there. Or actually it's tracking, I think, the decimals for the tokens. So we're gonna see that later, no worry. So then like we could see that we're going to be tracking accounts for set exchange, all the tokens registered for set exchange, and something on a block, which is using loopring. Basically, it like batches a lot of transactions. It's a rollup, a layer 2 rollup. It batches a lot of transactions and like transfer them to a layer 1 Ethereum in this case as a form of a block with a lot of transactions inside. So basically, we will be tracking like account created, account updated, block committed, and token registered. With all these events, we could like generate these different entities here. But one of the drawbacks that we're going to be examining right now with the templating and whatnot, since we are not using sort of a dynamic way of indexing stuff, we are just like defining what we want from this very specific contract. if we had like a clone contract of this one, another exchange, for example, we would have to like copy paste all this data like so. Well, I have it here already. Paste it and change a few things, like for example, change the name and the address. If you see here, this address is not the same as this address, and of course this name is not the same, it has to be unique. Just so we can actually index also the widx one. As we see here, we had this contract, which is the Lubric one, and we also had this contract, which is also an exchange, which is available on the Lubric registry contract, or however you want to call it, factory contract or whatever. So we actually want to avoid having to manually add anything to our manifest, because as you might expect, if we don't have this, we won't be able to index this exchange in particular. But if we wanted to start indexing in the future, we would have to re-index everything. We will have to deploy, manually create this. So manually like copy paste this code and actually deploy it again. So we could start indexing. So we will be like having to manually update everything. It really doesn't make any sense when we can like do it in a better way. So the way we are going to be refactoring this code, I actually already did it because we want to save a little bit more time. But the way we are going to change this is to use something like this. Let's go to the other contract. So as we said earlier, we already knew that there was a factory contract, which was called Loopring version 3, which is this one, I guess. Yeah. This one has a specific event. If I'm not mistaken, it was, how was it called? Let me check. Exchange initialize. So we could actually look it up here. This event will, why did it disappear? There we go. This event will allow us to like know the addresses that we want to index for all the exchanges that are going to be registered in this factory or registry contract. And since we have an event, then we can use as a hook, and we can listen for these events. We will know whenever a new exchange is created, or actually initialized in this case. We will know the address for that event. And this is exactly what we need when we are using templates to be able to, let's say, future-proof our subgraphs and have to and basically avoid having to manually update the subgraph code whenever a new exchange is available or a new contract. It doesn't really have to be an exchange, it could be whatever. So if we look at this implementation, we could be actually looking at a lot of other events. This Loopring factory contract has a lot of events, but the only one that we are really interested here, just for this example, is the exchange initialize, right? So let's see what we are actually doing with that specific piece of code. So on the handler, I don't know if you can see the code well. Is it big enough?
It's good.
Cool. So in the handler, we are going to be like creating an exchange. This is just to track, to have the entity, so we like have some persistence of the data. This isn't really needed for the example to work, but we are doing it anyways. We basically get a few parameters and save it as some fields just to have a little bit of data. And then the really important part is this one. We're going to be creating a dynamic data source from the template. This one is a template. If you go here, like we are importing Exchange v3 from the generated templates. If we see like the file structure, we could go like generated templates, and we have like this folder, which is template for the whole Exchange v3, right? So what this allows us to do is to call this specific method, which is create, with the exact address that we want to dynamically index at this very specific block. So just to put in context, every handler is called in a specific block. So part of the context of the handler is the block that it's being processed at. In this specific scenario, it will be called only in 2 occasions, since we only have 2 exchanges, and it will be called exactly in the block that the exchange was initialized, which are the 2 blocks that we had in the other manifest, which is like this one 9 million and something, and the other which is also 9 million something. So basically, what we need for data sources to work is 3 things, right? The ABI that it's going to be using, which in this example we already have, is the exchange v3. Then we would also need the address, as you can see here in the fixed or static data source declaration, and we also would need the start block. This is optional for the static data sources, because if you don't use it, it just assumes that it's 0. But since we are using dynamic data sources, it's been like inferred because of the context. So like we have the ABI here, the address for said contract here, and the block is the block that this specific handler is being run at, right? So it would be like 9 million and something, 9,000,000,000. It's inferred because of the context, right? So when we call this function, it will basically generate for us this kind of stuff, like this static data source implementation using this template right here. So it basically uses copy paste this and fills the gaps here. Templates don't have an address and an AV and a start block because it's used, as I said, dynamically in the code. So it basically fills all the gaps that you need here, like the address here, fills it, and the start block here fills it by context, right? So the only thing that you actually need to define for templates is everything except that. So you define all the ABIs that it's going to be using, all the handlers and functions that it's going to be calling, but you don't really need to define the blocks, the address and start blocks, because it's going to be like inferred by the context, and but whatever parameter you use for the others.
Will the initialization always be an event, or will we sometimes need to use block handlers or another handler?
You can use whatever you want. You could
Yeah.
use a block handler, you could use an event, you could use a call handler, if it's been supported by the change that you want to use, because some chains don't have call handlers and whatever, but there's no like difference. You could call it wherever you want, as long as it's a handler, of course, because it's the only place where code is executed. The only thing that you would need to know is to have available the address that you will be using at the time of the execution. So basically, we are using this specific event because it allows us to have the address available. As we said before, if we go to the browser, we knew beforehand that this specific contract would allow us to know like the specific address for set exchange, so we could use it as a dynamic indexing, let's say, entry point, right? So yeah, that's basically the only like caveat. You need to know the address that you are going to be dynamically indexing beforehand, or at least within the context of set handler. It could be a call, it could be whatever you want, right? And if we actually check it, it's probably being emitted in a call, right? So yeah, this is being emitted in the initialize exchange function, and that function also has the exchange address as an input. So we could actually use the call handler if we wanted. It's probably not recommended if you have an event handler.
What are the benefits of using an event handler?
It will be a little bit more performant and it's more compatible. So like call handlers need to have very specific nodes underlying nodes for Ethereum or whatever, to be able to use call handlers, you need to have an underlying node that has traces available, and only like Open Ethereum versions of the underlying nodes work for that specific purpose. So other chains like, I don't know, Binance or Polygon or whatever don't really use Open Ethereum nodes on the underlying graph node. So you don't have the call handlers available for those chains. So in that case, like using an event, it's like the best option, both as a performance improvement. I mean, it's not going to be called a lot, right? Because it's only going to be called a few times whenever a new exchange or a new contract is created. But events are usually easier on the indexing computing performance, let's say, and it's more available for any chain that you might use. So it's like a rule of thumb, right? It's better to use event handlers if you have them available. If you don't have them available, you could use call handlers or block handlers or whatever, as long as you have the required data to trigger a dynamic indexing, right? So yeah, I guess that might like answer your question. Cool. So if we go back to the code, now that we actually triggered this create function, we will basically have, let's go to the manifest, a new data source with that address that I used there, which will be indexing everything here. So all these handlers will be called, or should be called at least, if these events are triggered at some point in the exchange. And we will have like, there we go, these handlers being called and this code being executed as we would expect in the hard-coded version. So if we go to the examples, I already deployed them. It's the one with templates, it's still indexing because it's a little bit more heavy, I guess. Well, both are kind of heavy. Well, as you can see, the one without template is a little bit faster. One of the reasons is that it's only using one of the two exchanges, since I didn't like copy paste the other one. So it like managed to go to 90% when the other one is only at 83%. And they are most deployed at the same time, an hour ago and 44 minutes ago. So of course, if you don't have a solution that scales with time, it will most likely be handling less data. So it will most likely index faster unless the data sets are similar, right? The amount of data they have to handle. That's one of the, let's say, differences between both solutions. But of course, if you don't really have like the automatic scaling or automatically dynamic scaling that the templates allow, you of course are missing on a ton of data. And if you would want to like index that part of the contracts, you would actually need to manually deploy it. So I would have to like go to my code, which is here, right? I would have to go, where is my code? Did I miss it again somewhere? Oh, there we go. It's here. I would have to go to the manifest, as I told you earlier, copy this one, save it, and then I will have to like generate the code just in case. I don't think it's needed, but let's generate the code and then deploy it, right? No. It basically builds the files that we need. Hopefully it works all right, since the hosted service has been having a few issues as of late. It's deploying. Awesome. It deployed perfectly. Awesome. And we will have to refresh this. And oh, I had already deployed with the other decks. Well, never mind. Yeah, it's basically 90%. Well, yeah, that's mostly it. You would actually need to manually deploy, and let's say there's a new there's a new exchange here that we wanted to have that we don't already index, we'd have to like copy it again and paste it, fix indenting because it didn't paste it right. There we go. And change the name here, blah, blah, blah. And change the address and whatever, and check that everything is working, and then deploy again, and indexing would resume from the very beginning. So yeah, this is really not an ideal situation. If you have like a specific contract that creates a lot of other contracts, let's say it creates like 10 contracts per month, you would have to like update it at least once every month if you like wanted to have it at least somewhat up to date, or you might even need to manually change it 10 times every month if you wanted to have it extremely up to date. And you would suffer from all the syncing time every time because it would start over basically.
You would also suffer from once curation goes live on mainnet, the subgraph
Mm-hmm.
developer would also have to cover half the curation tags for curators who are following the latest version. We will get to know more about this pretty soon, and that would be
Yeah.
an enormous cost as well for developers if they were to upgrade on every new factory initialized contract. So
Yeah, I actually haven't thought about it. But yeah, you would basically have new deployments like every time a new contract goes live from the factory one, uh, which you wouldn't actually have to do if you were using like templates to cover this particular use case. So yeah, that's a really good point. It's incredibly useful for that specific thing. Yeah. So that pretty much covers how you would use templates. It's not really that difficult once you get the hang of it. It's just like calling a simple line in which it's the create one. It obviously have some implications on how you will debug it further, because since you are using like, let's say you have like 100 new contracts deployed on the factory one, then you would have like 100 data sources that could fail at any point, and you would have like 100 contracts that you might need to check. So yeah, it's like it's not perfect. You might like go into some issues that you might not understand at first, but it's not really that different from deploying a static data sources, right? So the only difference is that you would be using templates, and you would have to understand that there are many contracts that you are actually using, even if your code only states a single address, right? So in this example, this is the hard-coded one. We have two addresses, so we know if something fails, it's either in this address or in this address, the issue, right? But if you have like templates, if we go to this manifest, we actually don't know the addresses beforehand. Of course, we are, as I told you earlier, we are saving those addresses here in the exchange entity. That's one of the reasons why I'm doing it, because I want to know the address of something if it fails. But you also only really know beforehand the address for the factory contract, but you don't know every address that might be implicated in an issue. So yeah, it makes things a little bit more complex, but it's pretty needed for these use cases, right?
can you in any way
Mm-hmm.
filter which contracts you want to index? Say that there's a factory contract that creates a lot of create a new contract for each pair, but you only want each pair that includes USDC, for example. Is that possible to do? Is it possible to do some complex logic on which
Um,
contract you?
yeah, yeah, for sure. You could, as you see here, like since you are basically triggering those dynamic data sources inside a handler, which is basically a piece of code, you could like use like, I don't know, if um, contains USDC, right? I put this here, and it will only index it if it contains USDC. Of course, you would have to like code
Yeah,
what contains USDC means. You might need to like bind this address, do a few contract calls, check that this specific exchange has USDC in it, or some like weird logic, right? Like that, right? but you could totally index it in a filtered manner. So yeah, you basically have full control of what you actually dynamically index and what you might want to avoid.
Yeah,
Yeah,
great.
for sure.
Thanks.
Yeah, it's really useful. It can be used in many different ways, and it's quite a powerful tool. Yeah, and you don't really need to update it much often. Well, at least unless something breaks, right? But if it breaks, it will break anyway, so you will have to update it manually in that case. But yeah, it's really useful when you have like and this probably isn't the best example. Is one of the examples that I could find easily and that I could like change easily, because the loopring 3.1 subgraph, the actual one that we deployed, is incredibly more complex than this. I basically trimmed it out so it's easier to understand. But yeah, there's some other subgraphs that were like you might have, for example, in an exchange, in a Uniswap or whatever, if you were to deploy different contracts to manage different, I don't know, pools or farm strategies or I don't know, pairs, you might really find it really useful to use templates for that specific thing, so long as you have like different contracts that you want to index, right? So yeah, it's incredibly useful for that specific tool. Yeah, it might also work with like proxies, but it really depends on whether on like the specific proxy implementation that you're using. Like some proxy implementations trigger all the events in the proxy address instead of in the implementation address. So whenever that happens, you don't really need to index the implementation addresses, because it's not triggering anything actually. So yeah, in those specific cases when you're dealing with proxies instead of factories, like your mileage will vary, right? Sometimes it's really useful. Sometimes it doesn't really make sense because all your events and calls will be triggered in the proxy address. So for proxies, it's really dependent on the exact proxy implementation that you're using, but it might be useful for anyone that tries to like index proxies. But yeah,
So,
that's about it.
so first, for anyone who doesn't know what proxies are, could you just give us the
Oh yeah,
one
for
minute on
sure.
that?
Yeah. So basically, as we've seen, factory implementations basically create new contracts under specific like conditions. Like it might create under whenever you call a specific method, it creates a new contract or whatever. Proxy implementations basically allow you to upgrade the logic on a smart contract. So you basically deploy what is known as a proxy, which the only actual thing that it does is like send a call to another contract somewhere, which is where the implementation resides, right? And since you basically have a pointer to an implementation within the proxy, you could change the implementation that it's pointing to at any time, and in that way like upgrade smart contracts and have like a specific address in a smart contract address that you might change the implementation every so often to like update some critical bug or whatever. In these specific cases, you might um, want to use templates or not, depending on how you are sending the transaction to the implementation from the proxy to implementation, right? Because if the events and the calls are, let's say, emitted right in the proxy address, you won't really benefit from using templates because there won't be any events in the implementation addresses. But if your proxy implementation allows the implementation address to have their own events emitted, like I think it has to do with delegate calls or whatever. I'm not really sure. I'm not a Solidity developer. I'm mostly a software developer. But sometimes it triggers in the events in the implementation address, and in those specific cases, you could treat them like factory contracts. and do exactly the same thing that we did here. You basically use templates and you pretty much have it all covered. So every time a proxy implementation changes, you just create a new dynamics data source from that implementation with the new address, and you're all set.
What if a new data source needs data from prior blocks?
Yeah, that's a really good question. Like, that's the main drawback with templates, actually, since you won't be able to define at which point or at which block it will start indexing, right? The dynamic data source. And it only like allows you to do it from the block that you triggered it. If you need prior data, like let's say 10 blocks behind because the registry contract registered it like not at the exact same time that the contract was created, you won't be able to have access to that data, because the way that subgraph indexing works is it needs to be deterministic. You can't like generate a new data source that has to go to the back, like let's say 100 blocks back, or I don't know, 1,000 blocks back, and change the entities for those blocks, since you like the state of the whole subgraph needs to be the same at any point in time. You can't like change it with dynamic data sources. So that's basically one of the main issues with dynamic data sources right now. Mainly not so really complicated for factory contracts, but it might be an issue with registry contracts, since most of the time registry contracts might like register the exact implementation or contract or whatever it's registering at a later point than when it was first created. So there might be like a gap of data that you don't have access to. That's one of the many issues. You could argue that if you have access, like if you are developing the smart contracts, you could like take that in mind and make sure that whenever a contract is registered in a registry, it's registered at the point at which that specific contract started existing in the blockchain, so you don't have this issue. Of course, if you are only a subgraph developer, then you don't really have a way to change how the contracts work and whatever. That's one of the main limitations that I can think of right now. So yeah, it's a really, really good question. Yeah, it might be a possible workaround,
Yeah.
but it might not work every time, because let's say you prior to the point that you dynamically started indexing, right? You would need to reconstruct the state from the past, basically. And the way that you would handle it, as stated in the docs, is like trying to query the contract itself to check the full current state of everything that you actually care about in the contract, which might be something really heavy computationally speaking, right? But even if it's not, like, it won't be that specific data set that you try to like support from the past won't be created in the same way as you will for the all the data that will be coming in events or calls or whatever. So you might not be able to reconstruct it like 100% accurately and 100% full. Let's say there might be some missing data points or some missing, I don't know, some missing fields for the entities that you try to store, because those specific fields only appear in the events or the calls, and it's not like present in the contract state, right? Because you have to remember that subgraphs don't only like take the blockchain data and store it as is in a Postgres database and then like allow you to query it in a GraphQL manner. Subgraphs also process data. So in an event handler and a call handler, you might change a little bit of data. You might calculate some extra fields. You might like, I don't know, generate some analytics data or whatever, if you have like a really, really complex subgraph. And all those pieces that you will be able to create by handling the events and having everything at the moment that it actually appeared in the blockchain isn't exactly the same as just like reading the current state for the contract and copy pasting it to the database, right? Because you will miss like all these fine details, like the analytics data and like the calculated stuff or whatever. So yeah, it could be a valid workaround if you absolutely need to index this in a dynamically way, and you need to like support it with templates, and unfortunately it's a registry, and unfortunately the registry isn't exactly uh, it has some missing information because it's like registered at a later point, and you need to generate a workaround because you need it to index, right? I mean, it might be decent enough. It probably or most likely won't be exactly the same. So as long as you're fine with that, it works. And as long as you like take it into consideration when you are like trying to consume the subgraph data, but it's probably better if like you could have a factory contract that actually does it the right way, let's say. Of course, no one's perfect. There might be some changes when you're deploying smart contracts, so workarounds are sometimes needed, and this one is a really decent one. But you have to remember that it won't be like exactly the same as having the data available at the expected time.
Thank you, Juan, for being on. That was really insightful, and we've learned about subgraph using dynamic data sources for subgraphs. So thank you, and see you all in the next episode.
You're welcome, guys. Bye bye. See you in the next episode.